Hi, my name is Perry Sampson. I'm a professor of atmospheric sciences in the Climate and Space Sciences and Engineering Department at the University of Michigan. Here in 2017, we've been dealing a lot with hurricanes on a wide scale. Multiple hurricanes at once in the North Atlantic Ocean. So this is a teach out where we're going to talk about hurricanes. What's next? What can we expect? How do they form? How do they evolve in time? How do we forecast them? And ultimately, to what degree are these in any way related to our changing climate? So as we think about what's next, what we've done is gone to the university students and asked them for questions. An example is here.
It's a basic question. I never knew how hurricanes formed. So how did it form? How did it start off?
Well, that's a very good question from this student. And when we consider the storms that become hurricanes, we have to understand that they don't just become hurricanes immediately, they evolve over time. And they all include at least high winds and lots of water. And so we're going to go through how these storms evolve and how they obtain that much energy and that much water in such a short time, and how they're different from the kinds of storms that we normally see in the Midwest with maybe big snows and high winds during the winter time. So what is a hurricane? A hurricane is a combination of high winds and water. The storms that we have in the Midwest are often evolved because of large temperature changes between maybe the north part of North America and the southern part. Those big temperature differences cause changes in the upper atmosphere and lead to the formation of storms like this, a big nor'easter coming up the east coast of North America. But this kind of storm, as intense as it is and the destruction it causes, is nowhere near the energy involved in a hurricane. In a hurricane, and here with this example here in 2017, we have Hurricane Irma and Hurricane Jose right next to each other. We have that much energy wrapped up into the storm. These kinds of storms evolve from a wholly different process from those which affect us in the Midwest. And we need to understand the differences between this kind of storm and the more we call synoptic storms of the Midwest. The storms we have in the tropics, first of all, are notable because they have a great deal more moisture in them. Being warmer, the atmosphere can contain a lot more moisture at the warmer temperatures of the tropics. And that extra moisture is what drives a hurricane, which drives tropical storms. The energy from a tropical storm comes from the process of simply water condensing from water vapor. That change from water vapor, and it goes through the phase change into liquid water, releases a great amount of heat inside the clouds of a tropical storm, making the insides of the clouds much warmer than the outsides of the clouds, therefore more buoyant. So that kind of activity inside the cloud leads to the formation of huge thunderstorms. And this animation from NASA shows the cross-section of Hurricane Irma, where we can see the precipitation in 3 dimensions inside the storm. Hurricane Irma was 425 miles wide at its peak. Its height was about 10 miles high. So you put that together and we're talking about tens of millions of cubic miles of air, some of which contained clouds and some of which contained extremely strong thunderstorms. You can see the core of the thunderstorms here near the eye of the hurricane. Embedded in those are going to be the heaviest precipitation. Now we're going to talk as part of this teach out about how we can monitor these storms, how we're monitoring them now, and how we hope to monitor them even better in the future. Being that wide, these storms contain a great amount of liquid water, so much so that Hurricane Harvey over the state of Texas managed to drop 20 million gallons of water on the state of Texas, a remarkable amount of water, largely because that particular storm hovered over the state of Texas for such a long time, allowing the water to be drawn in from the Gulf of Mexico and continually feeding the clouds inside the storm. The damage in Hurricane Harvey over Texas was unbelievable, where whole neighborhoods were washed out given that amount of rain. 50 inches of precipitation in some places, a number even impossible to think about here in the Midwest. And the damage from it is across the board. Everybody in the state of Texas was affected in some way by this huge amount of precipitation, leading to great damage up and down the whole Texas seaboard. Now, let's back away for a moment and talk about what is a hurricane. And when we think about hurricanes, they come in stages. They don't just begin as a hurricane. They begin as something we usually call a tropical cyclone. A tropical cyclone is going to have a low pressure system. We'll talk in a minute about how the evolution of these things, how we become a hurricane from a tropical cyclone. It might become, if it grows in time, it could become a tropical disturbance where we have now winds somewhere around 30 miles an hour or less. It's still not destructive. Precipitation's begun. The storms are organizing into a cluster of thunderstorms. And over time, that cluster of thunderstorms may begin to rotate if they're far enough from the equator to allow the Coriolis force to kick in. Under those conditions, then we can move up to a tropical depression. Winds are now going up into 30 miles an hour or greater in a tropical depression. And over time, if it organizes and starts to rotate, then we get a tropical storm. A tropical storm is somewhere between 39 and 74 miles an hour. The point at which you hit 74 miles an hour, you now graduate into being a hurricane. And within hurricanes, there are still 5 categories of hurricanes that evolve from this point. As a forecaster, we're worried about 2 things. We need both a hurricane watch, which is something that would be issued some 1 or 2 days before landfall. And a hurricane warning is a point at which it's now going to make landfall, and at that point, you should have made whatever preparations you need to. The public needs to be aware of these 2 terms. When you get either the watch or the warning, the watch means it's time for you to start boarding up the windows. It's time for you to think about where you could go if things got worse. A warning is a time in which you need to start worrying about whether you should be evacuating to a safer spot. These are huge terms in meteorology that are all too often ignored by the public. Hurricanes come in 5 categories. This is called the Saffir-Simpson scale. And this scale is controversial these days because it only really expresses how hurricanes are measured in wind speed. But as we saw with Hurricane Harvey, these hurricanes can be very destructive without high wind speeds because of the amount of water they can drop in precipitation. So now we're thinking about new ways to express the potential damage of a hurricane. But these are based on wind speed. Category 1 is a wind speed of 74 to 95 miles an hour, entry-level hurricane. Now, every year I take a student from my class, Extreme Weather, here at the University of Michigan, put them in this wind tunnel on North Campus, and have them strapped inside. We turn it up to a Category 1 hurricane. And it's almost impossible to breathe at that speed because it's all you can be is keep standing even though you're roped in. Turn your face sideways and the air gets sucked out of your lungs. It's impressive how much energy even a Category 1 hurricane can produce. And yet the damage from this is very minimal. It's unanchored mobile homes, shrubbery, and trees. So this is not going to cause a lot of necessary damage. But it's also important to understand that the power of the wind is a function of the wind speed cubed. The power is a function of the wind speed cubed. So if I double the wind speed, if we go from 74 to 150 miles an hour, the amount of power that's in the wind at that point goes up by a factor of 8, 2 times 2 times 2. So there's great changes here as we go from Category 1 to a Category 2 like Katia was in the Gulf of Mexico here in 2017. When you get to Category 2, you're up to about 110 miles an hour, considerable damage to shrubbery, considerable damage to mobile homes and poorly constructed signs and piers. So we can measure the strength of the hurricane then based entirely on wind speed. And Category 2 hurricanes certainly are going to cause damage as Irma did when it made landfall in Florida. Category 3, now wind speeds are up to 111 to 130 miles an hour, almost doubled now from Category 1, so 8 times roughly the energy in these hurricanes. And low-lying escape routes are going to start being cut off when you get to Category 3. And at this point, if you hear there's a Category 3 approaching, you should have taken precautions at that point to get away from low-lying areas. Category 4, we just keep going up, now up to 155 miles an hour in a Category 4. This is a very, very destructive hurricane. At these wind speeds, complete roof structures fail, shrub trees and signs are blown down, destruction to mobile homes altogether. So Category 4 hurricanes, I can't express enough, are very dangerous, and those are to be taken extremely seriously. And the only thing possibly worse than the Category 4 is going to be Category 5 hurricane, as Hurricane Irma was, as it approached Florida. Category 5, wind speeds simply greater than 155 miles an hour, 8 times stronger than a Category 1 hurricane. All shrubs, trees, and signs are blown down. This is unbelievable, as we saw in some of the Leeward Islands as Hurricane Irma approached, almost complete destruction of buildings and vegetation in those areas. So as we walk through what's next in hurricanes, we're going to keep in mind the various categories of hurricanes and think next about what are the stages in the development. How do you get to a Category 5 hurricane? How come we don't have these every year? What's the variations from year to year? Why some years we have so many and some years we do not? Is it climate change? Are there other things involved? That's a very complex question to ask.